Hello, hello, and welcome to the last day of us using triangle congruence theorems to solve problems. And I want to introduce one new but kind of old thing, and it's a perpendicular bisector. A perpendicular bisector is a side that divides a line segment in exactly two halves and forms a 90-degree angle. Now, the word perpendicular refers to the 90-degree angle. The word bisector refers to the two halves. So, Ln is perpendicular bisector of MK. Let's mark this. The perpendicular part gives these two right angles, and the bisector part cuts MK into two halves. So, we have two right angles, and they are angle LNM and LNK. We also get two perfect congruent segments, MN and NK. I was going to say perfect halves, and then I saw the word congruent, but they're congruent, and they're halves of MK. All right, let's practice that another time. In number one, we're going to suppose that CS is a perpendicular bisector of AE. Let's draw that. First, the perpendicular part. That's the 90-degree angle. The bisector part is splitting the bottom into two equal halves. So, what are the line statements? AS congruent to SE. The congruent angles are angle CSA and angle CSE. Oh, I don't know what I did there, but that's a huge picture. Oh, right, I wanted to write, that's why. Suppose IO is a perpendicular bisector of CS. Are the triangles congruent? Explain your reasoning. Okay, let's see. IO perpendicular, that gives us two right angles. Okay. Bisector, that gives us two sides. So it looks like we only have two things that I marked. Is there anything else that I can mark here? Yeah, the middle. So are they congruent? Absolutely. These two triangles, triangle CIO and triangle SIO, are congruent by side, angle, side. Well, let's write that down. First, we have the two congruent sides. We got CO congruent to OS because IO bisects CS. Then we have the two angles, angle IOC and angle IOS, because IO is perpendicular to CS. And lastly, I can write that IO is congruent to IO because of the reflexive property. Awesome. Number 3. For the following figure, Tim determines that PN and CB are congruent. Well, let's go ahead and mark that. If he says they're congruent, they're congruent. PN, so it's a side, CB, side. He also measures that angle C and angle P are congruent. All right, let's mark it. P, that's an angle, and C, that's an angle. And then he says that the triangles are congruent, but angle, side, angle. Is that information right? Is Steve correct? I don't know who Steve is. It's supposed to be Tim. Is Tim correct? Explain your reasoning. Well, let's check it out. Does he have an angle, a side, or an angle? And an angle? No. He is missing that angle PNN is congruent to angle ABC. So he's missing that second angle. Well, let's take a look at Kevin in number 4. He determines that EK and AC are congruent. Let's mark it. EK, AC. Then he measures angle K and angle C, determines they're congruent. K, C. Then he measures DK and CB and determines they're congruent. DK, CB. Is he correct? Is this side angle side? Yes. He has a SAS pattern on both triangles. Hooray! We got congruent triangles. Good job, Kevin. And that is it for Unit 9. If you have any questions, please don't hesitate to ask myself or whoever else is helping you in math. Otherwise, have a wonderful rest of whatever day it is for you. Bye!